What's that? I've never looked at this before, so, but this looks like it.
Yeah, right here, like the testing and
Okay,
permit,
all right,
and then click features, campus, and then.
yeah. Yeah, that looks like it. Okay, let's get started. Let me get out of this here and see who's with us. Okay, answer to your names, please. Albright. Albright here. Yes, he is. Caron. Champ. Chavez. He's here. Heroes.
Here.
Johnson.
Here.
Jones. Martin. Meloy.
Here.
Mohammed Boy. Olson. Richardson is here. Sisson. Barney. Vasquez.
Here.
And Weflin is here. Okay. All right, so before I begin, concerning your test, which I have extended the deadline to Monday of next week, I think, right? Right, so you have until Monday. I've posted or published the answer keys for the 3 chapters, chapters 1, 2, and 3. And it seems as if I made an error in sending you back your graded work, according to what I've been told. Like, I may have sent inadvertently assignment 2 twice, thinking that I may have sent. I don't know. I don't know if I need to check and see what I've done. So, I'll correct that as soon as I'm able to do so. Definitely before end of business today. But in any case, at least you'll have the answer keys to study, so that would help you in preparation for your test number 1. And later on, I'll provide you your graded work so that you'll have that to review as well. Let me also say that so far, according to my records, I have only 4 students who have signed up on Skype and sent me their Skype contact requests. So if you want to earn that extra 10 percentage point to your first test, I would highly recommend that you do that as soon as possible, so that I can pass on that benefit to you when I've graded your test number 1. All right, so with that said, that's, I think, all I have to say by way of announcement. By the way, you guys out there in Zoom, can you hear me? Okay, good. All right. So, chapter 5 is totally dedicated to nomenclature. And when we're talking about nomenclature in chemistry, basically we're talking about the rules for naming compounds. All right. Very important, because after all, when people are communicating about certain reactions and so on, we have to basically know the rules for naming compounds based on their formulas and vice versa. And of course, formulas are very important because we use that in chemistry as a shorthand way of communicating, what the substance is, right? So it's very important that you understand the difference or the rules, I should say, when it comes to naming compounds. Now, if you watch the videos, which I said that you should watch, you'll learn that there are two types of naming system. You have the common and you have the systematic names. The systematic name is more in usage because it gives you information about the composition of the particular substance. Common names are usually in relation to the type of properties associated with the substance, and they're more arbitrary, right? They don't really communicate exactly what is present in the substance, right? Chemists, as I said before, we tend to use systematic names because the rules are clear in most cases. And basically, if you're given, for example, the formula, then anybody who knows the rules will know the name and vice versa. And this is basically what you're going to do today. The rules that we adhere to when it comes to naming compounds have been devised by an international organization known as International Union of Pure and Applied Chemists. And there's a particular division within that group, which meets, if I remember correctly, every 2 or 3 years. And their sole purpose is to come up with rules for naming compounds, right? Because every year, new compounds are being discovered. And sometimes what happens is that the new compounds are such that they do not fall into any of the previously devised rules that was put together by IUPAC. So therefore, they have to meet to decide on revising rules or coming up with new rules in order to accommodate the formation of new compounds. So just to give you some introduction in terms of the difference between common names and the systematic names or chemical names. If you look at, for example, I'm just going to choose an arbitrary one. If you look at, for example, Epsom salts, right? The actual formula is this right here, and this is the name. Now, even if you did not know the rules for naming compounds like this, if you look at the name here, you can get some ideas to the composition, right? At least you know that there's magnesium present, sulfur may be present, and hydrate usually indicates the presence of water. So even if you did not know what the formula is, you have some idea based on the name. Whereas in the case of common names, you cannot tell, all right, in most cases, right? So that's basically the advantage of using chemical names when it comes to naming compounds, right? If you know the rules, then basically you can tell what the composition is. And in some cases, especially when you get into organic chemistry, you can tell what the structure of the compound is based on the rules for naming such compounds. Okay, so what I'm going to do is skip a lot of this here and get straight into, let me just briefly mention ions, which are basically particles which carries a charge. And in the case of monatomic ions, such as in the case of potassium ions, you can have the formation of ions by either the loss of an electron, in the case of potassium, to form the potassium ion, or you can, and by the way, positive ions, such as potassium ions, they're known as cations, and the name of the cations is based on the names of the parent atoms, right? So potassium will produce potassium ions, sodium will produce sodium ions, and so on. Let me just skip all this here. The negative ions are known as anions, and they're formed as a result of an atom gaining electrons, such as in the case of the chlorine atom, gaining an electron to form a chloride ion. And in the case of naming anions, things are a bit different, because what you'd have to do is that in the case of the anion names, you're going to start off with the stem of the parent element, and then it always ends with IDE. So fluorine becomes fluoride, chlorine becomes chloride, bromine becomes bromide, and so on and so forth. Nitrogen becomes nitride, etc. All right? Oxygen becomes oxide, and so on and so forth. And then now you have to talk about, or we're going to talk about, the formation of an ionic compound as a result of combining anions and cations. The key thing you need to remember when you do that combination is that the result must be a compound where the net charge is 0, which means that the total number of plus charges must be equal to the total number of negative charges, so that the net overall charge of what is formed is 0. So for example, in the case of these examples right here, let's start off with the calcium chloride. What I would do is, because I'm a nice person, I provided for you the chart or the tables, which you can get from Canvas, and you can look up the ions and their respective charges. And that will help you to answer questions such as the ones here. These questions, they're asking for you to write down the formula for these compounds based on their names, right? So if you go to the chart, you'll see that calcium has a +2 charge, so that would be the formula for the calcium ion. And the chloride ion has a minus charge, right? So as I said before, the total charge must be 0 when you put them together. And the way that is achieved in this case is that you have to multiply the chloride ion by 2 so that you end up with 2 negative charges, which will cancel out the 2 plus charges, right? So when you put this together, the final answer would be, right? So basically you put them together like this. This 2 here becomes a subscript. And also very important, in the final answer, there are no charges because they cancel out, right? And that's basically how that is done. Here's another example. Barium phosphide. You go to the tables again, you look up barium. You see that barium has a +2 charge. You look up the phosphide ion, you see that it has a -3 charge. So again, you need the charges to cancel out. So you have to do a sort of cross multiplying here in this case. You're going to have 3 here, you're going to have 2 here, right? The total charge here is +6. The total charge here is -6, so they will cancel out. So when you put this together, the final answer becomes 3, and then P2. All right? Any questions? Okay, next one, magnesium. Let me do it here. If you look up the magnesium formula for the magnesium ion, you'll see that it has a +2 charge. In the case of the oxide ion, you'll see that it has a -2 charge, right? Now, in this case, you don't need to do anything because you have +2, you have -2. So all you have to do is put these together and you end up with MgO. And that's it. All right? Any questions? Any questions? Okay, so what I'm going to do is give you all assignment number 5 to work with. And I want you to focus on, let's see here. Part A. And in part A, it's basically pretty much what I just described in the example. So you're going to need the chart. You may want to put it up on your devices. Let me show you exactly what I'm talking about. Oh, I keep forgetting you guys out there in Zoom. Okay, for you guys out there in Zoom, let me see if I have published assignment number 5. Okay, apparently I didn't, so let me publish it now. So for you guys out there in Zoom, you can go ahead and get started on part A of assignment number 5. In fact, let me put it up here. Oops. Oh, wait a minute. I published the wrong thing. Or not the wrong thing, but... Oh, okay. So for you guys out there in Zoom, let me explain something. So there are 2 links for the same assignment, right? You have this one, which is chapter 5, and then chapter 5 addendum, right? So those are the 2 links you're going to need for chapter 5. Now, in this link here, for now, we'll be focused on part, we download it here, part A. So this is what you'll be focused on in part A. So let me help you guys out with the first one. Okay, so beryllium and fluorine. What the question is asking is for you to do is to give the formula and name the compounds formed between each pair of elements listed below, right? So the first one is between beryllium and fluorine. So you go to the chart that is provided in Canvas, and you look up the formula for the beryllium ion. And if you look it up, you'll see that that is Be2+, and the fluoride ion, which is F-, right? And as I said before, we need to make sure that the entire compound is neutral. So the total number of plus charges must be equal to the total number of negative charges. So in this case, what we need to do is multiply the fluoride by 2. And then when we put this together, the formula becomes BeF2, right? So that answers the part which deals with the formula. As far as the name is concerned, the name of this compound is beryllium fluoride. All right? And that's it. Any questions? Yes, sir.
Where did we go to find the table?
Oh, in Canvas. So let me do this. You go to where it says tables, and then you go to tables chemistry. Download that. Okay. And specifically, the information will come from this page, the 4th page, the 5th page, and the 6th page, right? So you have 3 different lists of common ions that you're going to use in order to answer those questions, all right? Okay, so going back to the assignment, let's see if you have got the hang of how to do this. So let's look at the compound formed between potassium and sulfur. So what would be the formulas of the ions firstly? K+, so the potassium has a +1 charge. And what's the charge on the sulfide ion? S2-. Okay, so how do we deal with this? Because remember, the total number of plus charges must be equal to the total number of negative charges, right? So how do we ensure that? Okay, so you multiply the potassium by 2, correct? So therefore, when you put this together, what's the final formula? K2S, very good. So what's the name? Potassium sulfide, potassium sulfide. Very good, all right. So now, you should be able to do the others. If you have any questions, of course, I'm here. But you should be able to do the others. I'm sorry? I've been having some issues with Wi-Fi in certain rooms here at the Citrus and also at the Ocala campus as well. Maybe you can share with her. She has the paper, hard copy. Yeah. Oops.
And oxygen. B, oh, it's just O2. So now we put the 2 lines to, yeah. Okay. 2, 2, 2. Yeah. European oxide. Yeah. And we did magnesium oxide. Or just be, so it's just MgS. Then this one. Begin to yeah, B6. So we got a
Yes, sir.
The spelling of sulfur, does it matter if we use F or PH?
It doesn't matter to me. It doesn't matter to me. The PH is the British way of doing it. Well, the PH is a non-American way of doing it. Because almost, well, not almost, every country except the United States will spell sulfur that way. In the United States, we use the F. But to me, it doesn't matter. It doesn't matter to me.
yeah,
Okay, let me see who came in late. Is Karen here? Karen,
One, two.
Mohammed Boy, Olson,
Here.
Sisson, Barney, oh, Sisson is here, okay.
They cancel out without you needing to multiply the just right.
Exactly. Which one are you referring to?
Magnesium sulfide, that'd just be MgS.
Magnesium sulfide, yes. That would just be MgS, you're right. Mhm. We're just focused on A for the time being, part A. Because I want to talk to you before you start part B. Oh, there's one thing I probably should mention. When it comes to naming and writing the formulas of these compounds, it's always the positive ion first, then the negative ion, right? So it's always a positive first, then negative, all right?
Oxygen is C2, it's O2 plus, O2 minus, C2 minus. So there's a two, C, that's two. Yeah. That's why in the ball, in this,
Oh, before I forget, Let me remind you about the possibility of earning more points on your first test if you sign up on Skype. According to my records, there are only 3 students from this class who have, no, 4. Only 4 students so far. So make sure you sign up.
Yeah, I just signed up this morning or last night.
Let me see.
Both we got the. Yeah, it's a customer see the two. Right to hospitals. And then 300.
This thing is slow.
Okay, we'll put 2.
Okay. What's your last name?
Jones.
Okay, I got it. Yeah, let me make a note of it.
They responded 3 weeks later.
Jones.
We'll put 2.
Okay, so I got you.
Did we do this already? I don't know. Which one did we do?
Okay, so are we finished with the A part? Almost finished? All right, let me give you a couple more minutes because I want to talk about the B part.
We did lithium and oxygen, and like before that we did potassium and sulfur. That's what I got mixed up. I messed up like 2 times. I got a. Very helpful. I don't use it as profile for my friend. And it's from junior. It doesn't take up
Okay.
space.
Oh, I did respond to you, Mr. Jones.
And then responded
Okay,
3 weeks
yeah,
later.
all right, yeah.
There's like a mini stage. I will be 3 part entries.
Weird that we can't access Skype using our school accounts, so I had to use my own account.
Yeah.
Oh, no, it's part.
Okay, all right, so let me talk about what you're going to do in part B. So in part B, you're dealing with what we call binary ionic compounds. Now, firstly, generally, we have a group of compounds known as binary compounds. They're so called because these compounds contain only 2 elements, right? So they're binary ionic compounds. Now, binary ionic compounds are made up of 2 elements, one of which must be a metal and the other one must be a non-metal. So that's kind of like a subset of binary compounds, right? So there are 2 types of binary compounds that you'll be dealing with in part B. There's one type where the metal part, the metal element, can only form 1 type of ion, all right? And some examples I'll show here. Well, first, let me deal with the rules for naming these compounds. For you to name these compounds, basically, if you follow this, you should be all right. You start off with the name of the metal part of it, then the stem of the non-metal part of it, and then you have an IDE ending. So I'm just going to go directly into some examples. Like in this case here, right? Sodium chloride, very simple. You have the sodium, you have the chloride, and that's it, all right? Stem of the name of the metal, then the stem of the non-metal name, and then IDE. Magnesium chloride, another example. Potassium oxide, another example. Sodium phosphide. And so on and so forth. So this is just basically some examples of elements and how you convert from the element name to the stem, or I should say the anion name. You use the stem of the name of the element, And you notice that they all end with IDE, all right? Now, there's another group of, and these are just some examples of binary ionic compounds. So you can see the relationship between the formulas and the names. Now, there is another form or another type of ionic compound where the metal part of it, the metal element, can actually form more than one ion, all right? So if you look, there's what is known as a stock system. There are two systems that we can use in terms of differentiating between these different types of ions from the same element. The stock system is the one that is more often used nowadays, but I've seen in chemical literature where they use the other system as well. So let me deal with the stock system. So there are certain ions that can display, or certain elements that can form ions with more than one charge, such as chromium, iron, copper, and others, all right? Lead is another one. Cobalt is another one. So there are several examples of this. So let me show you how the stock system works. In the stock system, let me clear this here. Okay, so in the stock system, and I'm going to use cobalt as an example. Oh, shoot. Okay, so in the case of cobalt, if you look in the tables, the same tables you're working from, there are two forms of cobalt, right? Cobalt ions, that is. One that carries a +2 charge, the other one that carries a +3 charge. So according to IUPAC, to distinguish between them by name, we call this one cobalt 2 in Roman numerals, and we call this one cobalt 3. All right? So that's how we distinguish between those two ions, right? So if I were to, let's say, write down a compound formed between this cobalt and, let's say, the sulfide ion, so CO2 plus combining with the sulfide ion, then the final formula would be COS. But if I were to combine cobalt 3 plus with the sulfide ion, then basically you're going to need 2 of these and 3 of these, right? So the final formula would be CO2S3, right? 2 different compounds, even though they're made up of the same elements. But because one contains cobalt 2, the other one contains cobalt 3, you have a different composition of the product or the compound, and therefore these are 2 different compounds. So the name of this one is cobalt 2 sulfide, and the name of this one is cobalt 3 sulfide. So in the exercise you're going to do in B, in some of them, you'll be, in the B part, you'll be given the formulas and you're asked to write down the names. And in the other half of the B part, the reverse. You'll be given the names and you're going to write down the formulas. Exactly. So, and you have to pay attention, as I just said, to those elements that can display or form ions with more than one charge. That's very important. So for example, in fact, let me bring it up on the screen here. So, where is it? Oh, here it is. No, that's not it. Hold on. Okay, let me scroll down. Okay, so let's start off with the first one. Let me write here. So you'll go to the tables and you see that calcium has a +2 charge. And the chloride has a -1 charge. Oh, okay. So these would be the formulas for the ions, right? So the name of this compound would be calcium chloride. Do the what?
The first part.
You mean like this part right here? No, you don't have to. But the reason why I'm doing this is because of the second question. In the case of the second question, if you look up in the table, you'll see that the nitride has a -3 charge. But in the case of iron, there are two types of iron. You have Fe2 plus and Fe3 plus. So the question is, which one is it, right? And the answer lies in the fact that, remember we said that the entire compound should be neutral, right? The total number of plus charges must be equal to the total number of negative charges. So if you have two nitrides here, which is suggested by the formula, the total charge here would be -6. That means that the 3 iron ions must have a total charge of +6. So if that's the case, which one of these two would be the iron ion that would be in this compound? Iron 2, Fe2 plus, right? Because if you have 3 of these, 3 times +2 will give you +6, which cancels out with the -6. So therefore, the name of this compound would be iron 2 nitride. All right? Everybody see that? Any questions? Okay, so if you understand that, then what do you think about number 3? Let's go to the tables. What would be the charge on the bromide ion, according to the table? No, for each bromide ion, for each, according to the tables. -1, right? So there's a minus charge on the bromide ion, and there are 3 of them, right? And the titanium, if you look at the table, I don't remember what charge is carried by the titanium. Can somebody remind me? What are the different titanium ions that you can have? Plus what? +4 and a +3. Okay. So which of these do you think would be combined with the 3 bromide ions? And there's only one of them here, right? Exactly. So the charge by the titanium must be +3. So what do you think the name of this compound is? Titanium 3 bromide. Right? And that's it. So if you understand those first 3, you should be able to do the rest of that part.
Here, we can compound that we're converting to this if we got an 8. So for CU3, it's 3.
Yes, sir.
What would number 8 be?
What's?
Okay, number 8.
Oh, you have them.
Well, it would be the beryllium has a +2 charge, but there's only one type of beryllium ion. Right, so it's simply beryllium hydride. Right, so in that case, and again, this is very important, folks. If the metal ion or if the metal part can only form one ion, one type of ion, no Roman numerals should be used. You see what I'm saying? Because according to IUPAC, that's being redundant. All right?
Okay, so we have to. Yeah. Just to help you. And then circle 3, because that's the one in the compound. We know that because Cu is what, just one negative charge? Because it's very different 3. Just 3 here. So we know this one for sure. We know bromide is 4 negative. So we had, and then we had to that 3 to was 3 that we have to multiply into. So we have 3 that we need to cancel out. -3 to cancel out. So the positive would be to cancel out the negative 3. That's good. Because we have the first one, and then we have, we don't have to figure out which one. Yeah, we have here, we have both of them, right? Yes, we have two options, and then we just look at the second one right here, and then we be like, okay, which one has out, and it would be this one, right? Yes. Because this one is, we have three of these. Oh, this right? Yes. Oh, okay. So then that would be titanium 3 gold. Let's see. Yeah. 2, 3. Then next, we know we have 3 of CU. How much P do we have? One P. What's the charges on them? B. I think -3. Be negative. And so just has to be negative. Because we have to find that gradient. There's 2. See, there's plus and then 2 plus. Must just be plus. Because in here it's multiplied by 3. So 3 times 1 gives us the positive 3, cancel out the negative 3. That's it. Or either be plus or is it a 4 plus 2? Yeah. Plus is plus up to 3 gives us -3 because of that. That was C with Papa. Papa, one. Yep. And Papa 1 plus 1.
Yes, sir.
Number 11.
Okay, let me clear this. Do this. Number 11, you said? Oh, okay. So in number 11, they gave you the oxidation, the charge for chromium, which is 6, right? So I would okay, so I would write this down as chromium 6 plus or plus 6. And if you look up the phosphide, it's -3. So in this case, I'd multiply this by 2 to get the charges canceled out. So the final answer would be CrP2.
Thank
multiply the two types of things, you have 4 plus or 2 plus. No, we know this one for sure. We have 2 SE with the negative 2. We multiply the 2 and the 2, we get -4. -4 will cancel out the positive 4. That's positive. So the section that's from here, right? Put it with the one that's closed, right? Like this. Yes. If this number is after this, I mean, you have 2 of these. You have 2 of this one. And then you can multiply this to cross out. No, they don't cross out. You multiply together just to figure out which one it is. I'm supposed to be if we were here. Oh, you multiply that because it's 6. And then here's 6. So you multiply this. And then when you call in these 2, and you cross that out because then it would turn into 1. This. We're basically just going backwards from what we do up here. It's 4. It is literally just 1 of 1.
So this,
Yeah, I'm just getting you guys started so that you get a feel for how to do this. And of course, if you have any questions, I mean, while you're at home, you can call me, on Skype. I mean, on Skype. Yes, Skype. Call me on Skype. And I'll be able to help you out.
Oh. Oh, gee. calcium, it's 3 plus. 3 plus. And then AS is 3 minus. And it's plus. So they just cancel out naturally. Yeah. I don't have this. Number 5. Yeah, so it's really easy. They just cancel out the. It's calcium also. That's it.
It's chapter 9.
No, hepta is 7. Oh, you're talking about covalent compounds now, right? Yeah, hepta is 7.
So then what's septa? Is that just not?
They don't use septa. No, they don't use septa. They use hepta when it comes to naming molecular compound.
That's it. I think so. Right here. Yeah. So you put 2 more sulfide. So it'll be this one. Or why can't we put the 2 here? Like that's not, we're going back to this, we're trying to find the equation for this basically. Oh, so this is just like that, because 4 doesn't equal to 2, because you only have one of these, so either it has to be this one or this one. It's basically like subtraction. Subtract this from this equation.
If you're finished with the B part, that's pretty much it for today. But I want you to complete the assignment. If you need help, like I said, feel free to contact me. It's going to be due next week. So that's one of the things that you have to do in addition to studying for your test. And there's also chapter 6 videos, which are published online. Chapter 6 is not a long chapter, but it involves balancing equations. So you'll get some exercise in that next class, all right? So
Our test is chapter 1 through 4.
1 through 3, yeah.
You want us to finish all these pages, right, before?
For next week.
Are we going to learn the other half next week, or do we have to?
We still have more time.
Well, you'd have to go back to the videos and so on. But like I said, if you need help, feel free to contact me.
This is all this stuff about ions.
Right. And polyatomic ions and all that.
Are we gonna learn that in class?
No.
Do it?
No, you can watch the videos, and I went through all that in the videos. So watch the videos concerning that. But like I said, you can also, contact me during my office hours.
Study for the test that I want to do. And I love. Oh,
Yes, sir.
Can you see if I did part?
Huh? Was it open book? No, the test is not open book. Is the test open book? The test open book?
No,
No.
the only thing you're gonna get is the same packet that I posted in Canvas with the ions and all that,
The tables?
the tables and all that, right?
Okay, is this chapter in the test?
No, 1 through 3,
It's 1 through 3.
yeah.
I mean, I have to go into it. Yeah, you got, but it's like the only day that I can't. I just wanted to do it on Thursday because I can't do it today. Because I still gotta study. I gotta do it today because tomorrow I am in Ocala all day.
Okay, for this one,
I'm working for that.
it should be S5 because you're gonna need 2 vanadium plus 5 and then 5 sulfide ions to get the charges cancelled.
Okay,
So this should be, take care. So this should be S5.
It shouldn't be P5.
No. No, the vanadium has a +5 charge, right?
Yeah.
The sulfide has a -2. So therefore, what's going to happen is that you're going to need 2 of these for every 5 of these.
Oh, I had it backwards. Yeah.
Right. So this should be S5 here, not S10. That's correct. That's correct. That's correct. Yeah, so that's the only one that I see. Let me see this here. No, gallium. I'm trying to remember. Is gallium? What's the charge? If gallium has more than one where is it? Oh, okay. Okay, so that's correct as well. Yeah. So that's the only one that you need to change. Yeah.
Thank
you. Mhm. Yes, sir.
It's supposed to be the radiation.
Yeah, so it should be more phosphorus than oxygen.
My O's and zeros kind of look the same, so I hope that doesn't look
Well,
like it's at 100.
What you can do for the zero, that's from students do this, is put the line through the zeros to distinguish it from the letter O. That works usually. You guys out there in Zoom, like I told the group inside here, that's pretty much it for today. So, yeah, I don't know if you have any questions for me. If not, I'm going to sign off now. All right. So I'll see you guys next week.
Before we leave, Mr.
Yes, sir.
Nicely, I have some questions about my assignment 2 grade.
Uh-huh.
I reviewed the answer key in my work,
Uh-huh.
and it seems that my answers are fairly close to the answer key, but I never rounded, and I don't remember if you specified rounding in the assignment 2 meeting.
Okay. I don't think I can look at that right now. But I'm willing to meet with you if you want to see me. Let me see, today's what? Today's okay, I have no office hours today or tomorrow. I do have office hours on Thursday from 11 to 2, and I'll be available on Skype so we can go over that. If Thursday can't work, there's Friday from 2 to 6. So those are the times I'm available.
Do I have to schedule a meeting, or can I
No,
just
Yeah,
join?
because I mean, you can either come in person or you can just call me on Skype.
Okay, okay,
All right.
okay.
All right. So you can do that and we can talk about it.
Okay, got it.
All
Thank
right.
you.
Thanks.
Have a nice day.
Yeah, you too. Take care.